Hello everyone, welcome back to Alkaline Hydroxide 784. Actually I was quite sleepy earlier. Maybe I'm a little bit less sleepy now, but anyways. So we'll be talking about a place where you don't really want to be sleeping in without some gear, which is outer space. I mean, you probably don't want to be ambushed by near zero gravity and suffocate from lack of oxygen. Anyway, useless sentence aside, today we're going to be talking about space. Yay! So the thing is, I actually know quite a bit about space. It's just that I don't think it's a good idea to just like go around explaining literally everything because all the stuff that I know comes from videos that you can probably learn better from. But I will tell you what's there to know about space to some extent, and maybe that will help you have a better idea of where to go and find out like what stuff to talk like to find out what's the thing that you need to think of when you hear the word space and stuff like that. Yeah, so I'll be covering it in a bunch of different subtopics, and you can see the subtopics in the timings slide here. So yeah, let's just start. Okay. We have a lot of stuff to talk about today. Okay, so the first one is, well, of course, the unexpected benefits of space research. So, like, the thing is, people may be wondering what's the point of researching space? What's the point of figuring out how to go to the moon and to Mars and to all sorts of places and all the other kinds of space research that's been done? I mean, mostly I'll be talking about what's the benefit from trying to go to space and do satellite related things. But of course, there's a lot of other benefits from other parts of space research, although they're a bit more related to the sciencey kind of thing. So yeah, I'm gonna talk more about this side of thing, like the more practical use kind of thing. I'm so sorry about the sentence I just said. It just doesn't seem to make a lot of sense. Okay, anyway, so the first thing that comes to your mind when I talk about okay, what is useful when it comes to space research? I'm pretty sure you guys will be thinking about satellites and stuff like that. So one of the most primary things that like one of the most like the first thing that comes to my mind is GPS, and of course that's based on satellites as well. But the idea of GPS was originally to track satellites. So yeah, the funny thing is like they wanted to have a system to figure out where the satellites are actually at. And the idea behind GPS is based on like the Doppler effect, which I guess I could try to explain. Basically, you have the planets orbiting and stuff like that, and there are certain points in which if you put something there, it won't move. So those points are called the Doppler points, and I guess you should probably go and read more information on that yourself because of course my mind is not completely awake, so I may not remember anything much. But yeah, it's pretty interesting, and I think they wanted to use that as reliable locations for their GPS system, so that the thing won't just move around everywhere and get lost. Yeah, so it's a actually quite useful part of space which allows us to not only for the practical use but also for actual space expeditions. The Doppler points are quite useful. Yeah, anyways, Doppler points aside, GPS is pretty useful in a way. It was, I mean, nowadays you don't see GPS devices. You only just use Google Maps or Waze if that's still a thing. But yeah, you don't really see a lot of GPS devices, but they're still being used in some places, especially when it comes to rental cars. You probably might get a GPS with it. Anyways, yeah, so they are quite useful, and that's one of the things that came out of space research. And apart from GPS, well, satellites help with many, many, many other things, and I think we all know that because we all like watch TV, we use the internet, we look at Google Maps, we know that's from the GPS as well. So, I mean, the satellites images, I mean, yeah, and even the weather information and everything is based on like predictions made by looking at satellite data. And there's so many other reasons satellites are very useful, and they can help us get a lot of information about a lot of things around the earth. And the special thing about satellites is that you can make it stay in a stay fixated onto a particular spot on the earth by flying it in a certain way, such that it is orbiting at the same rate as the earth, and therefore it won't like move. I mean, like if you think about it, like if you put it along the equatorial axis, then as the earth rotates about its north south axis, this thing will also be like same, like the line is going to be aligned with the same spot on the equator. Wait, why did I just say it like that? The equator, sorry. The equator. I think it's because I tried to say the word equatorial axis and then it just, okay, never mind, that's not important. So the satellite will be aligned with one point on the equator, and therefore you can probably like view a very specific spot on the earth constantly 24 hours, like literally each and every day. To you'll only see that one spot. Of course, not all satellites need to be doing this. Some of them need to actually move around and see different parts of the earth. So for that, you have to put them on different slightly tilted axis, or even just a completely perpendicular orbit, not axis, orbit. So like it's a perpendicular plane for the orbit of the satellite in a sense. I suppose images would make more sense for understanding what I just said. Okay. So yeah, that's the satellite. Um Apart from satellites and GPS, you might be surprised to learn that space research has actually like contributed to many other things that we may not even associate with space itself. And I think there's like this whole list of it on NASA's website, and you can probably just look at it yourself. But actually, the very first thing on the list was the most surprising, which is, or at least the most influential, I think, in my opinion, and that would be the smartphone camera. So you might be wondering how your iPhone can, take such wonderful videos and pictures. And yes, that technology came from space research. No wonder. Because, in space research, you need high resolution cameras and you need to keep them in small little devices so it can save space, you can save some weight on your satellite or whatever the thing that you're going to be flying. And yeah, for that, you probably need a really tiny and lightweight camera. And this is also very useful in your smartphone. So your smartphone camera actually comes from space research. Isn't that wonderful? You have a good reason to thank, to thank whoever's doing all this space research. It's not just NASA, there's also other space agencies. So yeah, it's we should thank them for this. Okay, so this is like the first part, which is that space research actually does bring us a lot of useful inventions and all, and it's useful in other aspects of life apart from just trying to explore the space. You need to like justify the amount of money you put into these programs as well. Even though that money itself is actually decreasing, and therefore NASA doesn't actually have a lot of like enough budget for some of their things. And that's a sad thing to hear because honestly, yeah, space is probably one of the places where you could afford to give a bit more money. Although, of course, before space, you probably have to prioritize stuff like education and stuff. But most of the time, the countries actually prioritize the military funding, so no wonder. Oh well. Anyways, so that's the first topic. So the second topic is about private companies and space. Yeah, so if I mention the word private company, I think the one that comes to your mind is SpaceX, which is the thing that's started by Elon Musk, and it's actually doing a pretty good job at doing what it's supposed to be doing. It has made like reusable rockets that manage to fly up and then return back. They've done quite a few tests on their stuff as well, so they've made quite a lot of progress for a private company, and there's a lot of potential that can be made, like that can be had from SpaceX. And apart from SpaceX, another company that I feel is somewhat more influential is what's that thing called, Virgin Galactic. Yeah, so we'll be talking about them in general. So what are the two things that could be that we could be talking about with regards to SpaceX, Virgin Galactic, and all the other space companies that are there. So the first thing is in terms of actual space missions and rockets and stuff like that. And the thing is, you might be wondering why are there like private companies and why are they allowed to do stuff when we already have like public space agencies like NASA and the Japan one, and then there's the European one, and then there's, and I guess a lot of other countries have their own one, Russian one, India's one. There's a lot of different space agencies out there. But why are we having like these private companies that come into the space and do stuff? Well, I guess it's more of, it's important to look at context here. As I just mentioned, countries tend to put more money into the military than into the space, and this is especially true in America. So NASA doesn't have a lot of money. And it is cheaper for them to like lease it out to private companies, because private companies might actually do a better job than NASA at being like economically like feasible in the sense, or at least they try to save money, and they at the same time try to be like effective at it, because they honestly wouldn't want to lose their own spacecraft in space. So they'll try to make sure that it will actually work at the same time. So NASA is, just getting a third party to help them do certain things that they may otherwise not be able to do due to insufficient funding and the fact that they are a public agency rather than a private company. So maybe the private company has better, like more motivation and potential to innovate, and that might help NASA in the long term. So yeah, that's the reason why they kind of allow it. And also in US, they like to make everything a business. So yeah, it isn't surprising at all to know that there's like private space companies. Anyways, that's not the point. I mean that is the point. That's not the only one. The other point is that there is this whole thing about space tourism. So what is space tourism? Well, the idea is that, in normal tourism, you just go to a country using a plane, and then you go and visit the country and do stuff. But in space tourism, what you can do is just take something that's like the space version of a flight to nowhere. But the nowhere basically involves circling around the moon, or just experiencing gravity, like weightlessness and things like that. So that's the idea of space tourism at the moment. And I think the other option is probably going to the ISS, which is already a thing that has been done. Like there have been people who have gone to the ISS as like commercial people. Like someone paid $10 million or something to go there. And that is crazy. Honestly, I don't see the point in like spending so much money just to go to the ISS. It's not worthwhile. Anyways, I mean, especially if you're a tourist and not like an actual scientist who goes there to do your work, like why? So there have been certain concerns about it, because obviously tourism of any kind can be quite environmentally taxing, and somewhere you're going to space, you require quite a bit of fuel to escape the Earth, because we all know as physics students, the escape velocity is 11.2 kilometers per second or per hour. Wait, okay, actually I don't remember. Per second, I think. Yeah, so you need to go really fast to escape the Earth's gravity. So yeah, and somehow, as usual, there's always people who are willing to go. They're willing to spend a bunch of money just to go to space and feel the weightlessness. Yeah, the only other thing I can think of in terms of tourism is the zero gravity flights, which are already a thing. They're a legit thing. You can experience them in USA or in Russia. And basically the idea is that you have people that you can go into the spacecraft. I mean, they don't actually go to space, they just recreate the feeling of the weightlessness in by doing certain cool acrobatic stuff. Sorry, not acrobatic stuff, by doing some cool moves with their airplane. So basically what the airplane will do, it will go up and then it will go down, like it will dive really quickly in a way that will allow you to feel weightlessness for a very brief period of time. And they'll do that a whole bunch of times, that you can feel it many, many times. And yeah, that's the idea behind the zero G. flights, and you can actually see it in your own website if you want, or you can watch the video where one of the some of the YouTubers have actually gone and tried them as well. It's pretty cool, I guess. And yeah, so that's space tourism. I think the last point here is space resources. So yeah, like space resources are even more interesting economically because they can be used here on Earth. But the thing is, who has ownership over these resources? I think that's the main concern that comes about when it comes to space resources. Like, because if you think about it, going to the moon and everything was like a country endeavor, a public endeavor. And when private companies like SpaceX and Virgin probably get involved, they could, that could change things in a way. And even without the influence of private companies, we need to know which country has the right to actually go and take the space resources and profit from them economically. So there's a lot of questions to be asked in that sector. But for now, what I can tell you is, like, what kind of resources are there in space? So the first one is regulate, and you might be wondering what in the world is that. And regulate is kind of like the soil thing that you can get from the moon. It's like the dust, the moon dust, or you can even get regulate from other planets. It's just that the regulate from those planets will be from the planets instead of the moon, will probably be of a different composition and have different properties. But usually when you're talking about regulate, is about the moon regulate rather. Yeah, so moon regulate has been shown to be quite useful in gardening or something, or at least if you want to go and have a colony on the moon, is quite useful for that purpose. So regulate is one of those things. The other resource which is more useful is stuff that can be found in asteroids. So you might have known that asteroids contain metals. Usually there's a lot of metals and stuff in the asteroid. And the most important metals over there are the rare earths. Of course, they're not necessarily rare on Earth because you can actually find them in quite good abundance. It's just that it's quite hard to get them out of the Earth. So, getting them in an asteroid nice and easily would be a lot easier than, getting them out of the Earth. It's like, and digging super low just to get your rare earths. And you might be wondering, why rare earths? Why not something else like gold or iron and stuff? Well, rare earths are used quite widely in smartphones and laptops and silicon chips and stuff like that. So, they're quite useful, and they're also used in the medical field. They're also used in many other places. And therefore, the demand for rare earths has been increasing quite a bit. And, having some asteroids to bring some free rare earths over here is quite, helpful in a sense. Yeah. I guess the difference between the asteroid and the regular is that the asteroid comes to us, whereas if you wanted to get regulate, we have to go all the way to the moon to get it. So yeah, that's basically it. And the final thing is water, and that is also there on the moon, and other places. I mean, the water, I don't think it's very viable to like go and extract water and bring it back to Earth because it sounds a bit stupid and would waste a lot more resources than it takes. But that's why then it gives in the sense. And I think it's more for if you want to have a colony on the moon. So yeah, speaking of colony on the moon, it'll be the next topic here will be the topic of life in space. So life in space would be like would have two different categories, and that would be either humans living in space or other organisms or living beings living in space. So we'll talk about how humans could theoretically live in space. So at the moment we have the ISS, and I think that's the closest thing to humans living in space. So in the International Space Station, there's actually a lot of logistics that goes into the International Space Station, and that's pretty cool to know about. But like apart from all the logistics and the food, like the gravity balancing, and like recycling the water that they drink and then excrete. And like literally so many other things that you need to worry about on the ISS, including the scientific experiments and the well-being of the astronauts themselves, because staying in space for too long can be taxing on your health in many different ways. I think you've heard of it before. Usually it's like the effect on the bones and muscles, and therefore the astronauts have to actually exercise every day in order to minimize that effect on them. Yeah. So yeah, ISS is probably the closest thing we have to living in space per se. And it's been quite successful. It's been going on for so long. In fact, it started as something else, and it it kind of became a thing. Yeah, so it's pretty interesting to see that the ISS is still up and running and doing like many useful things for science and Earth in general. So apart from the ISS, where are the other places we could go and potentially create a space colony or do anything of that sort? So there have been a few candidates, and I'll just talk about them briefly. So the first one is the moon. And as I mentioned earlier, the moon has regolith, which you can probably use to help with your gardening. Although the moon's atmosphere is still not really the best. It doesn't have enough gases to do certain things, but it could still try to grow stuff on the moon. And it also has some water, so you could try to extract the water from the moon. And theoretically, if you want to look at it from a very theoretical scientific perspective, the the most like the best way to actually stay on the moon is to have like these little dome colonies, and you have to stay inside that dome as make sure that you get your resources from the regolith and the water and all that stuff. And most certainly you might need some solar energy to make sure everything is going well. And yeah, I don't actually remember all of the details of how you can stay on the moon and all that stuff. So apart from the moon, we have Mars, and Mars has been quite a subject of much news, like not just lately, but for many years. So yeah, we have like Challenger, and we have like we have all the stuff that has been found out about Mars. So Mars does have some ice. I mean, the problem with Mars is that it doesn't have any atmosphere. And there are definitely reasons why that's the case. Well, it basically lost all of its atmosphere early on, and now it doesn't have much of an atmosphere, and therefore you can't really stay there unless you create an atmosphere. And there have been like solutions proposed for it, which is to to purposely create global warming in the sense, and to plant a lot of plants in order to make sure that there's some kind of air in the atmosphere. And apart from that, yeah, I think it's pretty similar to what they've proposed for the moon, like in terms of the space colony. But the additional thing is the atmosphere issue for Mars, and for that they have to actually create like to create greenhouse gases and also oxygen at the same time, and make sure that there's enough gas in the atmosphere for people to actually stay there. So yeah, that I think those two you have heard of definitely, but there's a third candidate which I doubt. I'm not sure everyone would have heard about it, but those who are enthusiastic about all the space news will probably know about this, and that is Venus. You might be wondering, Venus? Really? How? Venus has like such a toxic, really inhabitable surface, and its atmosphere has got sulfuric acid. So, can anyone actually even live on Venus? Well, you might be wondering that, of course, and yeah, it sounds quite crazy to actually stay on Venus in any case. But yeah, the theoretical way of possibly staying there is actually in the sulfuric acid atmosphere, because that's where the temperature is close enough to Earth's temperature. It's about 30 degrees Celsius. Yeah, I'm not kidding. It's actually about like Earth temperature there. And the thing that was proposed was like little floating space pods. You know what I mean? Like it kind of looks like the uh how do I put it? Okay, never mind. Just show an image of it or something. So like little floating space pods, and you have to stay inside that pod for like forever. So yeah, that's pretty much it. it's weird, I guess. So yeah, I know I didn't write it down, but there's another one which is like this, which is not nothing to do with the planet, but it's more of that, that big, is it like a Dyson sphere or something? So yeah, there's this proposed thing which is like a spherical or even a donut shaped thing where you can create a living environment within that structure and have like all of the outside surfaces covered in solar panels to get energy and stuff like that. But the problem with that issue, like the problem with that solution is that it requires so much resources that, like, so many resources that you probably wouldn't have enough on Earth just to build it. So yeah, I guess the only other way is like for now the general consensus is that if you really want to colonize in space, the first place you'll go to is the moon, of course, and from there get other space missions to go to other places. So that's the idea. To first set up like a temporary like stopping point in the moon, and then from there you can go to other places and see what you can do there. Yeah, speak apart from humans, what else can stay in space? Or there's probably other organisms if we are lucky and we find them. But of course, there's also this sense of eeriness that we're probably the only place where there's life in the whole universe in a sense. And that sounds quite interesting and also weird at the same time. And therefore, there's been like a constant search for life in space. So once again we go to the same bunch of places to some extent, yeah. We have not Earth's moon but Europa, which is quite which has like this whole block of like layer of ice, and then underneath there's an actual sea of water or something. So there could be life there, but we have no idea yet because it's too far away. I believe Europa is Jupiter's moon, right? I believe so. If I'm saying it wrong, then sorry. Oops. So yeah, the Europa and probably even Titan, I guess. Yeah, there's like a lot of wait, or is it Pluto's moon? Okay, anyway, there's a bunch of different moons that are not Earth moons, but a bunch of other moons that could potentially have life or life signatures in a sense. So that's Europa. Apart from Europa, we have Mars once again. But Mars is probably like not right now, but maybe long, long ago when it actually had an atmosphere. It could have probably had life at that point of time, but not right now. Because there are definitely signs that there was actually liquid water on Mars, or these seas of water and stuff like that on Mars. At the moment, all of it is now like locked up in ice and things like that. But there used to be actual seas on Mars, according to what they've observed on the surface of Mars. And of course, Venus again. You might be wondering, wait, there's actually things that live in Venus? Well, we don't know yet, but there was a finding that there was actually phosphine coming from Venus. And you might be wondering what is phosphine. It is considered a life signature because like according to the scientists, it doesn't make sense for Venus to be emitting so much phosphine because most of it would have gotten destroyed if it was just natural phosphine production. So it's likely that there could be life forms producing this phosphine in large enough amounts to be detected here on Earth. So that's the idea. Um, and you might be wondering, where exactly are these life forms? Once again, they're in the sulfuric acid atmosphere. And the proposed theory is that they're like little microbes and little droplets of water. And as they agglomerate, they'll sink down to a lower level, and at that lower level the microbes will stop like actually functioning, and they'll just they stay like like how animals hibernate. These microbes will just hibernate, and once they get pushed back up to the okay zone to live, they will continue with their life as usual. So that's the idea behind the potential life in Venus. So yeah, that's Venus. And here's the last one, which is really, really unusual, and I'm not sure if I even understand it fully. And the idea is that there are life forms in, is it in the black hole or in the sun? Yeah, so in the middle of the sun or something. And these life forms are not like normal traditional life forms that we know here on Earth, because of course that's actually a very important, interesting assumption that we might make when you're searching for life on other planets. Like we assume that we have phosphorus dependent and oxygen dependent life on other planets. The only reason why I mentioned phosphorus is because phosphorus is there in many of our cells, if you haven't known that already. But in outer space, there could be other things like arsenic, and that could be used instead of phosphorus. That's possible. And yeah, that's a thing. But arsenic is toxic to people and mice and some certain living beings here. But it has been found in some other living beings that are more hardy and are able to withstand the arsenic. And therefore, it's possible that there are entire life forms that use arsenic and are actually, they find phosphorus toxic instead. So it's possible. Anyways, apart from arsenic and phosphorus and things like that, the thing that I'm gonna tell you right now is so unusual that you probably won't understand won't like believe me. So there was this like scientific theory that there's potentially quantum strings, like the life forms are quantum strings of information. And you might be wondering, what does that even mean? I don't know if I can even explain it myself. So these life forms like exist in the sun or something. I hope so. I kind of forgot where exactly they were supposed to exist, and they just like constantly regenerate and do stuff. And I think you should just watch the video to find out more about it, because I honestly don't think I can explain this. It's just too quantum to explain already. Yeah, so that it is completely different from what you would envision a life form to look like. So yeah, but it's still a theory. We are not sure if it's a legit thing or if there's even potentially, it's like if that's even a thing, is it even possible? But it's a theory. uh right. So enough of the life stuff. Let's talk about other kinds of sciencey stuff. So in terms of sciencey stuff, there's been quite a few sciencey stuff that has been there about space, and I think I probably cannot cover everything because there's honestly way more sciencey stuff than I can think of. So yeah, I'll just cover what I can remember at the moment. So the first one, which kind of interests a lot of people, is black holes. Because we got a photograph of a black hole and stuff like that, and that's pretty cool. But what is the kind of thing that we've found out about black hole? What kind of information have we found out about them? Well, first off, we know how they work to some extent, and yeah, the idea is that they suck in matter, and as matter goes beyond the event horizon, which is like this ring around the black hole. Once it passes by that event horizon, it is the point of no return. It'll undergo spaghettification. Yes, that is an actual term. So basically, just be elongated so much until it's no longer recognizable, and it will be destroyed. The information will technically be destroyed. But is it possible for the information to be retained? Well, I have no idea. I think I've read something about that before, like whether the information is truly destroyed or is it possible to recreate the information. And you might be wondering what I mean by information. Well, for example, in order to create a human being, you can't just have like all of the materials that you require, like all the elements and the phosphorus and the carbon, the oxygen, the hydrogen, like literally everything that you would need for creating a human being. Just bringing all that stuff together isn't going to work. You need information, which is what is contained in DNA. So likewise, if we put something into the black hole, will the like all of that matter is going to be completely like obliterated back into the smallest particles possible. So is the information itself destroyed? I think that's what is generally happening here. But is it possible for us to read to get back the information, even though not in its a former state but in a scrambled or like a broken down state. Is that possible in the sense? So that's one of the things that you could find out about black holes. And yeah, so I was talking about the event horizon just now, and you might be wondering, how do you actually visualize the black hole? How do you know that it's there? Because it's literally just black, and the space is also black, and therefore you can't see anything, right? So the thing about the event horizon is that it is the point of no return, right? So it's possible that there's some matter or light that is still there that can actually escape. And this light, also comes with the radiation, which is called Hawking radiation. So Hawking radiation can also be emitted from the event horizon as light. And this is usually radiation that kind of escapes in the black hole, because the black hole also does emit a bit of radiation, and that is called Hawking radiation. And that's how we can actually see that they are there to some extent, but of course it's not super visible still, but it's possible to detect this radiation and then find out, oh, there's a black hole here. And you know um, we'll find out if you can get a picture of a black hole that way. Anyway, apart from black holes, well, another thing that they might remind you of is wormholes. So yeah, wormholes have been suggested as a theory for time travel through science fiction and stuff like that. So I'm not sure they actually exist, but the theoretical idea of a wormhole is that you can enter and exit from different points in space and potentially even time by going through one of the holes, which is like a black hole, and then coming through the other, which is like the opposite of a black hole. But that doesn't make sense because, as I mentioned earlier, there's this whole issue of black holes destroying information. So let's say if you were to enter a wormhole, would you be able to get out of it? I have no idea. I'm not sure how that works or whether it's even a thing. So it's kind of like more theoretical than actually, is like actually possible to use one or see one and things like that. So yeah, that's wormholes for you. Apart from black holes and wormholes, one of the other interesting theoretical things is, I guess you probably heard about dark energy and stuff, so I probably won't try to explain that further. But yeah, those are like the normal stuff that you've heard about in space. But there's something that's really really crazy that some people may not accept at all because it's just too far fetched for them, and that would be the multiverse theory. And I'm not sure if I've already mentioned it before, but the multiverse theory has, five, like 4 or 5 stages of multiverses, and that is pretty crazy, right? You might be wondering, wait, there's more than one stage of multiverse. I mean, I think most of you would already, be somewhat familiar with the idea of quantum universes, right? Because of each quantum decision, you can have two different universes splitting off. And then that can split off into multiple infinite universes. But apart from that, there's other forms of multiverses, and I think you probably have to watch a video to find out more, because if I explain it, it'll take another 20 minutes. I don't know, waste any more time. It's already like 38 minutes here. Oh no. Right, so multiverses are a theory, and apart from multiverses and all that, yeah, I don't think I can think of any other really crazy things that I've heard of in terms of space, but there have been quite a few crazy theories that are out there. But at the same time, I am willing to listen to a theory. It's not that I don't accept it or anything, but at the same time, it just boggles me. It's like, wow, multiverse. How does that even work? How do you visualize a multiverse? Yeah, anyways, that's crazy things aside. Let's look at more measurable, down to earth things like gravitational waves. Yes, so if you've heard of the four basic forces, the strong force, the weak force, the electromagnetic force, and the gravitational force, the gravitational force is the hardest to detect. It is actually very weak. And there is a system here on Earth called LIGO, which allows us to find the presence of gravitational waves. So how LIGO works is that it uses a bunch of lasers, and the lasers keep like repeating, like reflecting to the two different mirrors again and again and again. And by doing that, it can increase the distance of the laser travels by a lot. and this will allow it to detect small changes in gravity and stuff like that, and therefore it kind of detects gravitational waves. So what do they do with this? Well, they can find out if there's any black holes colliding in a certain direction, and that's pretty cool, right? You can use it for things like that. I mean, the uses are more like space related than practical use, but yeah, you can do lots of cool stuff with LIGO. And apart from LIGO, there's a new technology that's been proposed, and it's not like a thing yet, but it's possible. It's theoretically possible, I think. So the idea is to use some quantum diamonds because they can do this whole laser thing in a much smaller space, and by being quantum, makes things so much more interesting already, and so much less understandable. So yeah, we have like diamonds that can help us do this whole laser thing without using really huge spaces like LIGO does. And it could be even more precise than what LIGO can achieve at the current moment. So yeah, that's in terms of the sciencey stuff that I'm willing to talk about. I mean, there's a lot of other things that you can talk about when it comes to space, like the dark energy thing and all that stuff. But honestly, there's already too many things in one video. So the last topic, yes, there's still one more topic. Oh my gosh, the last topic is called "End of the World?" question mark. Right. So I know it sounds like a very sad way to end the episode, but it's a thing. I just happened to put it in that order, so what can I do? So, you might be wondering, what about the end of the world? Well, there's two scenarios. One is the end of the universe itself, which would probably only happen like millions and billions of years later. So you don't have to worry about that at the moment. But there's some interesting theories about it. Like for example, because the universe is expanding, right? It's so the first theory is that it could stop expanding and then suddenly crunch all together again, or it could just like slowly just keep expanding until everyone is so far from everyone else that we cease to see anything, even with light coming to us. So yeah, that sounds pretty sad. Everyone just becomes super lonely. Or it could be like everything just stops and slows down, and the universe no longer can do things. Or it could just explode all at one go and just disintegrate and become go back to that point before the Big Bang. So yeah, stuff like that can happen. And as I kept mentioning in this whole video, there's a lot of videos that I put links for, so you should probably watch those videos for more detailed explanations on any of the topics that I mentioned here. So apart from the universe ending, well, the more pertinent issue will be how Earth can be threatened by space. So there are two options that are more well known, and the first one is of course meteorites. And I'm not gonna talk about aliens and stuff like that because honestly, why? Why should I talk about that? Well, I want to talk about things that are more realistic in a sense. So we'll talk about meteorites and another one which is a bit underrated, in fact. So meteorites, well, we do have this worry about some meteorites or asteroids or something hitting the Earth from far apart, from like far away. And we do have like methods to supposedly divert them, but at the moment we are not in much danger. And even the ones that are likely to that have some chance of coming close, well, that chance is super, super, super tiny. So we do have like certain backup plans, like yeah, I mean, it's not like these plans are already in effect or anything, but there's theories and stuff like that. And the only one that I can remember is the one where they want to use satellites or rockets that are powered by solar mirrors or like solar foils. And these foils will be pushed by the sun and like the solar energy, and that will propel these little rockets or satellites or whatever you want to call them to help nudge the asteroid away from Earth. And yeah, the most like a feasible way of doing this will be to start way earlier than if when the asteroid comes really close to Earth. Make sure you start like from really far away, because it's easier to push it by a little bit and then allow the course, like the part of the part of the asteroid to take course on its own, because as long as you nudge it by a little bit really far away, when it comes closer, it will still be away from Earth. It won't hit the Earth. So it's possible for us to deflect them by, you know, doing it much earlier than you would expect to do it, of course. Like do it way earlier before it even reaches Earth, and make sure to push it just a little bit, just enough gravity to push it a little bit to one side. Oh yeah, by the way, I didn't mention this earlier in the sciencey stuff, but actually it is possible to say that gravity isn't a real force, but is rather a product of the fact that space-time is curved. And that is interesting to take note of. But yeah, like honestly it doesn't matter because most of us will not be doing physics that involves such fancy understanding of gravity or anything, but it's just an interesting thing to note. Yeah. So apart from meteors and stuff like that, what else could threaten the Earth? Well, of course, it's a solar flare. And this is probably one of the most underrated dangers that could, be posed to Earth, because it is a very real thing that can happen. And yeah, solar flares have happened before. So what are solar flares? Well, it's basically when the sun starts acting up and like the the stuff on its corona, which is like the crown, the coronal part of the sun, and the very surface of the sun will have like little outbursts of plasma and stuff, and they will just create little loops and things like that. And these outbursts are usually not too big, so they stay relatively confined to the sun's area, like the local region. But sometimes they can shoot out a lot of stuff, and that stuff can go all the way to Earth, and that can happen. And in fact, there's a lot of particles from the sun coming to Earth every second of every day. So, but most of these particles won't really cause much of an issue because the Earth has a magnetic field and that is protecting us from the sun. Thanks. So, yeah, you might be wondering then why do you have to worry about a solar flare then? Well, it is possible for the solar flare to become so great that some of it does actually pass through the Earth's magnetic field. And when that happens, well, it won't pose a threat to our lives per se, but it will pose a threat to the electrical systems and the communication systems that are there on Earth right now. And that will be a disaster. It would pretty much ruin a bunch of devices. And the last time it happened, it wasn't so bad because people weren't so dependent on devices. But right now, listening to this video on a device, you're probably gonna do something on a device for pretty much the entire day. So if you think about it, it's gonna be quite bad if our devices all gets fried by the sun. And there's even this whole documentary which suggests that people will probably just suddenly become all chaotic and crazy and start killing each other and stuff, because without electricity, the produce in the supermarkets will probably get spoiled, and bad things can happen, and it's gonna be a mess. Honestly, I'm not sure what will happen, and there are definitely ways to protect us from solar flares. So yeah, it's actually a avoidable danger, but in many countries, this is not being done. Like there have not been that many protections or stuff done to actually help the grid not be affected by a major solar flare. So yeah, that's about it. I think that's about all the stuff I wanted to say today. I was actually seriously considering splitting this up into two, but I honestly wasn't in the mood to write a actual script, so I just decided to be more concise and direct you to other videos instead. And even then, it is almost 50 minutes running, so honestly, what am I doing? So, yeah, this is like the second last episode of GPO season 1, and the next episode will be the final episode of season 1. But that doesn't mean that GPO will end. It will, in fact, be continuing with season 2 and so on. It's just for me to get a little break in between the two seasons, and also to consider if I want to make any design changes, or just spice things up a little bit, make something look different. I don't know. although to be honest, it's more of a continuous process rather than a suddenly one-time process. I change things and then it suddenly becomes different and stays like that forever. But it's more of like a continual evolution of GPU. Anyways, I shouldn't keep you waiting. You should probably go and do other things, I guess. So if you found this video useful, I hope you did, because space is one of the things that a lot of us may not like actively go and pursue information on. So yeah, it's useful to know a lot of information about space, even though you don't really need to know all the nitty bitty details. You just need to know what's going on and what's happening at the moment and how that can impact the rest of us on Earth as well. So space is actually a interesting topic to talk about. So yeah, I hope you find this video useful as a starting point to learn more about this particular topic. So if you did find the video useful, please press the like button and subscribe. And with that, I would like to say thank you and bye.